So this video is going to be about Git, the program Git. And many of you are software development majors, and so you're going to deal with software. And a lot of you will use Linux in your coding. And while the coding environment that are out there are definitely running on Windows also, but the majority of coders a lot of times use Linux to code. So Git is a tool that will allow you to maintain what's known as repositories. So I'm going to show you a little bit about how that works. And so the software tool that was designed in order to um, solve the problem of code revisions is called Git. And that is something that we install on our Linux system. And that program, which is called Git, is a program that is similar to any other application program. It doesn't necessarily link to a specific server. And so I'm going to show you really quickly what that Git looks like. And let's see. Here we have now what I have is I have a folder that I made in my home folder called Git projects, and this it really should say GitHub projects because these are projects that I've gone in and cloned from a particular repository. So we call them repositories, and that is short for repo. Okay, and so any code base that will give you basically a tree of code is called a repo. So I'm going to just use the Git program, and we can kind of look at that real quick. Um, so normally what I would use Git for is if I'm building software, I would use it to keep my changes in a very specific level. So I could make some changes, I could commit those changes, make some notes about them, and then next I would push those changes to a repository where they could be pulled by others. And so when you use package management, essentially it's a very similar process to that. That code has been, except for the fact that the code is bytecode, so it's been compiled. A lot of times the code that comes from Git or GitHub is source code, but Git is independent of the websites that use it. So when we look at GitHub and this is GitHub.com. So this is actually a site that's owned by Microsoft, but uh, it's one of the largest software rep- repos out there. So I can take any project that I have created, and I can clone that project. It's called cloning, and what I'm basically doing is I'm copying the files that are in the GitHub project, and when I clone this repository right here, notice it's the status is public. What I will get is I will get a tree. I don't have any folders or anything listed out here right here, but I just have 3 files. And so when I um, when I actually clone that repository, I'm going to get those 3 files and copy them down, whether they're source files or binary files or what have you. Now, this is an example of this Vivala DAV and bits of bytes. This is an example of just some source code that I pulled down so I can use a demonstration in the video about compiling software. But when I actually told Git to clone this repository, what I did was I came down here and I got this URL and I copied it. And then I went to my terminal and I said git clone, and then I pasted that link. And so what Git did at that point is it went through and it actually cloned that particular project and it put it in a bits and bytes folder right here. And so what actually happened is the whole repository was copied, the file and folder structure was maintained, and we can see that in each one of these folders is a different little application, and we could actually compile any of these pieces of software and run them. Now I did that, and I built one of the little tools I built, which was it read the CPU utilization information um, from yeah, here it is, CPU usage. So this is one that actually started with source code, and it was a shell script which would compile that source code into a binary file. And so the green indicate that these are executable files. But that's the consumer side of Git and GitHub. So GitHub is again the website that's up in the internet. Um, I could use Git to send data up to sites like SourceForge, right? Or there's other Git sites. So it's not just GitHub. GitHub is the largest one. Um, but notice right here, 14 Git hosting services compared. Right, list of 5 Git repository management systems, 6 places to host your Git repository. So these are good places, good ideas to come and if you want to actually share some source code with the world, you don't have to do it on GitHub. You can do it on other places. GitHub is just the one that I chose. Now, um, in order to actually facilitate that, and if I want to contribute to a project, and I would my first thing would be to clone the repository and learn about the code and the code base and what's going on. So I'll show you another one that I did, and this is an interesting one because it is it's an actual real-time shooter video game. And so when I look at this particular project, there are lots of source code files. The CPP files are the source code. The headers, the .h's are headers. So lots of little mini tools that they've been building in here. And this is a real-time shooter game. It doesn't compile yet. There's still some stuff missing in it. I think they're compiling it by pieces at this point. But even the images here, we can actually look and see those images, and I'll go through some of that when we look at the compilation of the code, and we'll show that in another video. But this is just to show you about Git. And so with that one command of git clone and then the URL, I was able to basically clone this repository. Now I can go in and I can look at the code, I can make changes, but at this point, I do not have a way to commit those changes back up to the source tree. So in order to do that, I would need to make a pull request, and it would allow me to go in and, as you can see here, the pull request. So in order for me uh, To do that, I'm going to go here to pull request, and we'll look and see. So this is where I would create a pull request, and it would be like, hey, look, I want to send some code back up here to the project, and have it looked at so that we can get it in there. This is how the projects actually come alive, and teams of people could work on them. And so an open source project movement can literally have hundreds of people that work on the software and work on parts and pieces, and this project begins to come together as the changes are approved piece by piece. So this was a extremely different. The software movement used to happen through the Usenet news groups and other FTP servers that were set up. The invention of Git and sites like GitHub and others, software repositories, changed the face of computing greatly and changed the open software movement in a big way. So if I want to use Git, and I'm going to go in here and show you my repository. Now, there's a couple things that have to happen. Now, before anything happens, I'm going to go into my temp folder, and let's see. I have what I have done is I have cloned my repository inside my little temp folder, and we'll show you that real quick. There you are. Okay. Now notice that I'm not using my / here to get to this folder, and the reason why I'm not is because I don't want to start at the root. I want to start at the location where I'm at right now. So when I look at this folder, this is the folder that I cloned my DLD2517 repository in. And because I did that, I have this little folder called Git in there. And if I go in there and kind of look and see what's there, I can see that I have logs that actually shows what was happening in my project. And so this is the actual log of what has happened in the project and what's been added, what's been removed. So this is how the program will know what the status of it is, when the last time it's been updated, and other things like that. So before I could actually push a file back up to the repository if I made a change, I have to have a signing key in order to actually make that sign. And so and it will, let's see, let me show that just in case I wasn't showing that screen. This is my repository Git folder, which controls everything. Um, and then also I want to show you the signing key. We're going to go now. When I go through and actually sign or try and push the repository up to Git, it does give me a URL at some point, and it says you need to go to this URL because your login and password, it doesn't work at this point. And so I had to go to the URL, and it took me through actually creating two different keys. So I have a GNU Privacy Guard key and an SSH key. Now these particular keys are these are public keys, and so when I send data up to the server, I'm going to use my key to actually digitally sign the data, and it's going to verify what I send it with the key that I've entered in here. And it will actually it'll give me a guide. So notice it says check out this guide to generating SSH keys or troubleshooting common problems. So everything is in here as far as how to do it, to generate a new key. Now this is for SSH. So this is where the connection actually will occur, and it will get my computer connected up to the GitHub servers. So you'll utilize the key, and I use the program called SSH-keygen, and it's telling me that I'm going to create an elliptic curve key, and then I'm going to sign it with my email address. And so it will actually create a public-private key pair, and I will secure that key with a passphrase. And then when I do the secure shell connection in order to update to GitHub, I'll be asked for that passphrase. And I'm going to take you really quickly through that process of pushing up to the repository. But the other thing that I had to do was I had to create a GNU Privacy Guard key, and the GNU Privacy Guard key is just another key. It's very similar to the SSH key, but it actually signs the code that I send. And so it takes me through the process of creating that key. And once I create it, it's just a text document. It's really easy. I just paste it in. So let me go back to my profile here, and you can see. So right here, if I want to make a new key, I could just say new SSH key, and I would put in a title for it, and it would just tell me to paste it in. And so that's all that I do. The same thing for the GNU Privacy Guard. To sign my code, I just paste it in here. Now, if I go into my repository and I don't want to look at the logs just yet. I will look at the logs though. I'm going to go ahead and create a file called intro to git.md. Now, MD stands for Markdown. Markdown is just a way to write. It's not an HTML, but it is a way to turn regular text files into HTML by a processor. So I can do things like numbered lists and make headings and bold and italics and things like that. So notice that VI automatically interpreted Markdown. It's turning things bold and bold, normal font. The headers are there. So I'm just going to go ahead and I'm going to save this file. So this would be where I would put in my source code or some other code. And I need to go ahead and add the file to the repository, because what I'm going to tell Git is that I'm going to track that file. And the next thing I need to do is I need to commit it. Now what I would generally do is I would just use an asterisk right there, and I would commit everything. And that would be the fast way to do it. But if I wanted to just commit the files that I made changes to or added, I could do that. And so what will happen here is it will automatically go into VI because I didn't include a message on the command line. It wants me to actually put in a note. So I'm going to do that. Added a sample intro MD file. Okay, so I'm just going to put in a little note here, and I quit. The next thing that's going to happen is Git is going to automatically utilize GNU Privacy Guard to sign the file, and GNU Privacy Guard is prompting me for my passphrase. I don't have to have a passphrase, but it's a secure way to make sure that only I'm able to actually modify the code. So now that that's done, now I get to do push. Now notice that I'm asking for another passphrase. This is the passphrase that's actually going to create the SSH connection. They could be different passphrases or they could be the same. It depends on what you want to do. So this was the actual connection where what we did was we compressed the information, we compressed the code into a archive, and we connected with SSH up to GitHub and sent the data over. Now we should see a couple different things. One is we'll look in the logs, and we will cat head again. And we can actually see that there has been a change. There should be a change. Well, maybe there hasn't been. Let's see. Yeah, there is a new line here on the bottom. Um, we can see that the commit message here was added a sample intro MD file. That's the one that I added. So that's the new log entry. And we'll look at the browser and we'll go back to GitHub. And what we should see is here's my new file, intro to Git. And notice that it actually interpreted this and made a little bit of a update. If I had done 2 number signs, it would make it bigger. 3 would make it bigger than that. So, um, but that is now this could be any type of code, right? So when I go in and I clone that project using this URL right here, I will have a copy of that project file in my folder. So that is Git, and that's this cloning. It's actually adding a file to the repository, committing the repository, and signing the code, as well as uploading it to GitHub or whatever your repository is. And that is how modern day code bases are modified and manipulated. So this is something that you will more than likely use and want to use in your time as a developer or administrator.